Good afternoon, everyone. Today we are choose one basic topic, logic gates and its applications. Uh, in digitization, we have to learn what is the basic gates and what are the actual logic of that gates, and after that, what is the applications. Before moving towards, we see the main definition, logic gates. Logic gates are the fundamental building blocks of digital system. The name logic gate is derived from the ability of such a device to make a decision in the sense that it produces one output level. In some combinations, input levels are present. There are just three basic type of gates: and, or, and not. The fact that computers are able to perform very complex logic operations systems from the way these elementary gates are interconnected. We in the slide there was one image. This is the switch in the home appliances. We are using that switches. Here we raise the one question: what are logic gates? In the binary lesson, previous we learn number systems, binary, octal, hexadecimal. In binary lesson, we discussed the switches inside a computer. Now, logic gates are the switches that turn on or off depending on what the user is doing. They are the building blocks uh, how computer works. This is the either on or off. There is a two conditions, means all of you learn binary system, binary number, either 0 or either 1. Means we are taken here one image of that switch. Now logic gates turn on when a certain condition is true. Means when the turn on, in that case we are calling that is the true condition. And when off, in that case we are calling false condition. They either spit out of the answer, that is the true or false, means either on or off. Means you have to remember, true means on, means it is the 1, and false means off, it is the 0. Before we moving towards an example, uh, some basic part, the input and output of logic gates can occur in only two levels that we learn, on or off. These two levels are termed high and low, either true or false, or simply 1 or 0. Here we taken one example, that is the on, they are equal. Means here we taken same value, means in that case here we give the rule itself is the equal. Here is the taken we different value, means it is not equal. Yes, here we get logic gates provides the off, is indicating the false. Same here we taken 1 1, in that 1 1 logic gate work, it is the 1, means it will be the true condition, 1 condition, on condition. Here we taken different, 1 is the on, 0 is the off. It will be given to the logic gates, means we gets the, means it is the changing the values. different values, means we get the 0, means this is the off conditions. Types of logic gates, basically we told that basic logic gates and or and not, but here major logic gates we are using not, and, or, and XOR. There are also other ones such as NAND, NOR, XOR. We will cover that. And this is also called as Boolean logics. In circuit schematic, each logic gate is represented by different picture like the shown. This is the one schematic. Here is the NOT, and, or, XOR, XNOR, NAND. All the gates will be given in pictorial manner. What is the NOT gate? In first one, NOT gate, also called as an inverter. NOT gate is also called as an inverter. It has an only one input and only one output. It is a device whose output is always the complement of its input. Means whatever the output will becomes, the output it is the complement of input. Means it is the opposite. The output will not get assumes the logic 1. Output means it is the when assume output is the 1. In that case, the input we have to get 0. The logic symbol and truth table of inverter, it will be shown in next slide. Here also given the details. Another name of NOT gate is inverter because it inverts and makes opposite the input. This is a simple, is it having one input, one output. The details will be given here. The output here we taken a y is a true if input A is false. Means here is the false, here is the true, here is the true, here is the false. Means it is the opposite, means it is the inverse condition. Here we take an input and output. When we given 0, will be gets 1. When we given 1, will be gets 0. In Boolean logic expressions, we are calling y equal to a bar, that is the not bar. Without bar, it is the only positive value. When you putting the bar, it is the not. Alternative notation we also a complement, otherwise a inverter. There is another not function. Next one important, AND gate. AND gate has two or more inputs but only one output. The output assumes the logic 1 statement only when each one of its input is logic 1 state. The output assumes the logic 0 state even if one of its input is at logic 0 state. Hence, the AND gate is also called as an all or nothing gate. Here also given, unlike a NOT, AND needs two inputs and more inputs. It turns on when both inputs are on. Here we given the details. Here we input 1, here is the given input 1, we generates the output 1. But when given input 1, another input of 0, in that case we get the false value, means 0 value. When given 0, 0, in that case also we generates the 0. Details will be given here. And truth table, this is the input, this is the input. 0, 0 will be yes the 0, 0, 1 will be yes 0, 1, 0 will be yes 0, 1, 1 will be yes 1. This is the detailed slide will be given here. Description, logical symbol, 0 0 will get 0 0 1 and get 0 1 0 0 1 1. Boolean expression means output a into b, it is the multiplication, means a into b, otherwise a dot b, otherwise we are also called ab, that is the AND function. This is the total related to the AND function. Now we move towards the NAND function. Means it is the opposite part of AND. Here we given description. Output Y is false if inputs A and B are true. Means when we get the true values, we get the 1 1. In that case, output will be false. Means we get the 0. A bubble is an inverter. This is an AND gate with an inverted output. See here, when you do an input 0 0 0 1 1, means only when true values will be given we generate the output 0. Remaining time it will be ones. And how you write in Boolean expressions? Same as we written in a AND gate, but it is the opposite condition of AND gate. A into B bar. It is a bar, it is noted as inversion. Means A B bar. Next, OR gate. OR gate may have two or more inputs but only one output. The output assumes the logic one state even if one of its input is in logic 1. OR gate is also called an any or all gate. It can also be called as an inclusive OR gate because it includes the condition both the inputs can be present. Here given the details, or we require two inputs, one output. When we given one true value and one false value, in that case it generates 1. When we given false values, it will be generates false. When we given true values, it will generate true. Given truth table, where 0 0 we get 0, 0 1 1, 1 0 1, 1 1 1. Details will be description will be given in truth table 0 0 0 1 1 1 0 1 1 1 1. Boolean expression will be written in the output, means y equal to a plus b. That plus it will be indicates or symbol. In descriptive, here will be it is called as logical symbol. NOR function, same we learn AND and NAND, same, or it is the opposite of NOR. Sorry, NOR is the opposite of OR. Here will be given description. Y is a false if input A or B is true. Means when your true value will be gets, it will be generates false. This bubble is as an inverter for the output inversion. Check here. When true value will be generated, output will be false. Means what happen here? When false, two values are false, two inputs are false. In that case only it generates true value. The remaining times it is the false. In Boolean expression it will be written y equal to a plus b bar. Next we move toward the XOR. XOR is the short way to exclusive OR, like OR XOR also only needs an input to be on or it to speak out on. It is also off when both inputs are off. Here we given two inputs XOR symbol, already having two inputs, one output logic. Since XOR gate produces an output 1 only when the inputs are not equal, it is called an anti-coincidence gate or inequality detector also. The symbols will be shown here. Two inputs, whatever when true value will be given and false we generate true. Same we will learn in truth table also. Here 0, 0, 0 we get 0, 0, 1 we get 1, 1, 0, 1, 1, 1, 0. Here we take the tree of gates that depend on each other. Means we see different types of gates. Here not gate, or gate, we connected and also land. Means that is the tree of gates. We that is called as stacking of logic gates. Means what? One logic gate can be an input to another logic gates. We take the one example also. Here is the NOT gate. When you given one input, it generates the 0. Same 0 will be given another NOT gate, we gets the output 1. Take the second example. Input is the 1 for NOT gate, we generates the output 0. That 0 will be given as an input for AND gate, and another one input, it is the 1, means 1 0 of AND gate, it will be generates 0. This is the stacking of the gates, tree of gates. Here we connected 3 gates. AND gate 1 1 will be generates 1. OR gate 1 0. Here we take compulsory 1 0. It generates 1. Then 1 1 will be given as an input for XOR gate. It will be generates false value, that is the 0. We seen the as blocks, logical symbols. But logic gates, it is an actually look like wired bugs in a real life. The image will be shown that we are also in our daily life, we are also called as IC. This is the different types of gates. We learn for the easier for the understand purpose. Here we taken one example to taken one circuit given three inputs A, B, C. Here we taken truth table and Y is the output. A and B is the given input for AND gate, and A it is connected for the NOT gate, but it is the input for AND gate, and C is the given for AND. Whatever the output of first AND and second AND will be given to the OR gate, and we get the output. Here we taken three inputs, hence 2 raised to 3, hence we get the 8 combinations, hence we prepare truth table 0 0 0 to 1 1. We learn stepwise, we check the stepwise. The first step, when you given 0 0 as an A B, AND gate says that 0, means first AND gate gives the output 0. That 0 will be goes here. There is a NOT gate, hence it here generate 1. Means 1 0, the AND gate will be generate 0. And 0 0 will be given to the OR gate. The output of Y, it will be generate 0. Same second step, A is the input 0, B is the 0, 1 is the C. 0 0 will be 0, 0 will be given to the NOT gate, 1, 1 1 will be 1, 0 1 for OR gate, that is 1. This is the steps. We check stepwise. This is also called Boolean logics, stacking of trees using of different types of gates where we connected and we got the one truth table, logical truth table, and after that we got the output, that is the A B, and here is the not, hence A bar C. First AND gate generates A B out, and here is the A bar C. That A B and A bar C will be given to the OR gate, or will be notified that plus sign, hence A B plus A bar C. And it will be in truth table. A and B will be here, both values are positive, we are taken true. Yes, A and B here is only two times will becomes true. Here this is the notified. And here is the A bar C, means here is the A bar means false value, and the C is the true value, hence here is the 1, hence we are taken here. Means here is means we got that two values for AB and two values for A bar C. That is the total 4 value. That is the Boolean expressions. Next one, AOI logic. That is the AOI logic means A, it is AND gate, O means OR gates, I means inverted gates. Same we taken here diagram. It is a tree of gates and not and or. Another logical different types of arrangement, NAND logic, NOR logic. Check next one. This is the special application, NAND gate application. Given input, we got the output. This is the bubble. That is the say that inverter means what will be happening in NAND gate. Either when you given 0, in that case both will be 0. In that case the output will be generated as 1. When will be given 1 then input, both inputs are 1. In that case output will be 0. The in remember purpose in truth table of NAND gate, when both values are true, in that case output will be generated 0. Remaining type it will be always it will be 1. Next, for NOR gate application, in same this is the symbol already we learned. In truth table the logic will say that when both inputs are 0, in that case output will be 1. Remaining type it will be 0. This is the application of logical gates. It is the half adder circuit. This is the AND gate OR gate. In half adder we require a sum and carry. Already we learned in previous video, that is the binary addition and binary subtraction. That is in addition sum and carry, in subtraction that is the generated borrow. Here is the we got the equation for the sum, that is the x y bar y inversion plus x inversion y, that is the sum. For carry purpose x into y. Same for the x and y, that is the XOR gate, hence we are taken x XOR y, and C is directly connected to AND gate, hence x and y. This is the basic Boolean identities. And some laws, the identity law for AND form and OR form, that 1x equal to x in AND form. For OR, that is denoted by the plus sign, means 0 plus x, it is the x. Null or dominance law, 0x it is 0, 1 plus x is the 1. That is the idempotent law, x is the x, x plus x is the x. Inverse law, x into x bar, obviously it will be 0, but x plus x bar it is the 1. Commutative law, xy it is equal to yx. In R form, x plus y is equal to y plus x. Associative law, in bracket xy in bracket z, outside the bracket z is equal to x y z. Same for OR form, x plus y plus z. It is x plus y plus z. Distributive law means it is given in tabular format. Same De Morgan's double complement law, that is x double bar is equal to x. It is a very important law for the logical evaluation, logical expressions. We have to solve in next videos also. This is the ICs we are using. This is the NAND chip IC, that is the 7400. Means in NAND chip IC this is the notch. Here we require 5 volt DC supply. That is the 4 and 3 it is the input and 2 it is the output. Same for 6, 7 input, 12, 3 input, 9, 10, and remaining 8, 11, 5, 2 it is the output. It is the bubble will be indicated, that is the inner line. Next I see that is the NOR gate IC 7402. Here is the pin diagram, and it is the using symbolic diagram. 2, 3 input, 1 is the output, 5, 6 input, 4 is the output. Here is the given in pin diagram the details input output pins, the ground and the voltage supply pin also given. Here 2 input AND gate 7408. The total pin diagram is given, 15 pin IC is given, and total voltage the 1 2 is the input, 3 is the output, 4 5. That pin diagram, pin description will be given here. It is given in diagrammatically. It is easy to understand, and I hope you understand all that basic logical gates in today's lecture. Whatever the question will be raised, you put on the comments. Please give the like and subscribe the video. Thank you very much.